All right, now, micrometers. So we talked earlier about measuring stuff, right? And we talked about all we're doing is dividing an inch up into smaller parts. It might be mostly off camera. We'll measure down here. So all we're doing is dividing up, right? But when you're talking about micrometers, we're dividing them up into thousandths of an inch. So that's what we're going to talk about. So we have the basic micrometers. We have a set. And I only have these four. They go up big, like to 12 inches or more, right?
Is this the one for Microlocks?
Nope, this one. They can't see it because we're over here. We'll talk about that one in a minute. That one's different, okay? So we have four of these, right? So they do different things. This does up to 1 inch. This does 2, 3, and 4 inch. So I only go up to 4 inch because I don't measure that accurately, and I probably don't even need these, right? I don't use this one very often. Even though it's all beat up, I got it that way. It's not because I use it a lot, right? So we need to talk about how to read these though, right? They all work the same other than you need to change sizes, right? So if I wanted to measure something that was over like this, I couldn't measure that with this one, right? Look, it won't fit, right? But I could probably measure it with this one, right? So the only reason they have different sizes is because they only measure 1 inch at a time, and the frame changes so that it can measure bigger stuff, right? So let's get these big ones out of the way and we'll learn how to read this one. All right, so it measures little tiny stuff in thousandths, right? So here's what we're doing. Measures thousandths, right? So we're gonna measure how thick this ruler is.
Gotta be pretty small.
I think it is. So we're gonna clamp it on here. And notice it's got this ratchet, right? And that is so I can't over torque it. Because right now, if I do it with my fingers and I said right there, we're about 22 right there, right? See the number 22 right there? And watch what happens if I crank it down. What's it read now?
20.
I just squished that down another 2/1000ths of an inch by cranking it tight, right? So if you use the same tension every time, you get the same measurement every time. It's hard to do that with your fingers, right? I get pretty good at it, but you need this, ready? You need this. And that means it always has the same tension, so it's always at 22, right? So when we measure this, we're going to go up and we're going to put it in here. We're going to crank it down, and it actually is 22 thousandths of an inch thick. So if we had thousandths up here, we'd have 500 here, right?
Not divide it 1,000 times.
250 there. 22 thousandths would be way down here, right?
That's thin.
Pretty thin. We can measure the thickness or the width in thousandths too. Let me open it up. How about you measure this one? All right, get over in the middle. All right, so hold a ruler. Oh, I can hold a ruler if you want. Hold that. All right, we're gonna open it up. You're not open far enough. Keep opening it. All right, now we're gonna hold it in here. You got the ratchet. All right, now hold on. You got it slip. You let it slip. So we need to get this in there. Click it. Oh, it's slipping on me. It's hard to do this sideways. Right there. Now we're going to tighten this wheel, and this is our lock, right? That wheel will lock it. And now that measurement is locked in, and we can take our time reading it without losing it, right?
It looks like it's 4.
Good job. So we're going to start with this number, right? It goes up to 4. So that means we're going to start with 0.4.
And where's the pointer? So
You see these lines? Each of those is 25. And how many of those do we have? No, just between 4 and the edge of this thimble.
2.
2. So it's 25 plus or times 2. 25 and 25.
50.
50. That means that we need a 5 there. And then we look at our thimble numbers, right? So 0 is here. We go around there, and we want to line it up with this line right here. And what do we end up with?
That line looks like it's on 7.
It's a little bit above 7, right? But that would be 457 thousandths, which is, I always use this as like a half-inch measurement. Remember, half-inch is 500, right? So I'm probably not doing a very good job, or maybe I wore it down. or we measured it wrong. But I always use this as like a 1/2 inch spacer. So I probably ought to measure it more and make sure it's a 1/2 inch, because 457 is a few thousandths shy of a 1/2 inch, right? But that's what I use it for. All right, so let's measure something else. What else do you want to measure? Ooh, let's measure, oh, there you go. Let's measure this, Scribe. And screw her down. Lock it so our measurement doesn't get lost. Wiggle that out of there. All right, what is that one going to say?
Looks like it says 2.
All right, so we're going to start at point 2.
And that little line here is would be on the 11.
Well, how many lines we got between the thimbles still, though?
1.
And that's 2, 5, right? 2, but we can't have our 5 yet because guess what? Look at all these other numbers. So we need to take this 5 that would normally be there and add all of these thimble numbers to it. So how many thimble numbers do we have? From the 0.
1, 2, 3, 4.
Well, they got numbers. That's 5.
5, 6, 7, 8, 9, 10.
Well, it goes past.
11.
It goes to 11, right? So we need to add. Oops, wrong way. We need to add them this way, right? So if I add 11 to 5, what do I get?
We had 5. 16.
Not 16. 11 to 5. 11 plus 5 more. No, you're right. 16. I was doing it wrong.
I was doing 11 plus 5.
Yeah, you're right. 11 plus 5. I think I might have my decimal in the wrong spot, though. Let me do my... Hold on. It's hard to do this when I'm talking to you. So 25... No, you're right. That'd be plus 16... Yeah, 25, 30, 35, 36, right? So we'd add 16 to 2, and that would get us 36, right? So we would be 36. So that would be 0.236 inches, thousandths of an inch, right? So we can measure these. I don't usually do the paper math. I do the way I do it is I count them. So if I start on a random number like this, I look and I go, okay, that's 2, 5, right? 0.25, and then I go, that's 50, that'd be 60, 65, 73. See how I did that? I just added, and when I turned the spindle, I added. That's how I do it. I'm sure some people do this right in their head and come out every time, but I'd mess that up. So that's how you measure micrometer. I'm going to make you measure with this in the future too, right? I'm going to teach you how to measure it. This one you were playing with is different. Kind of the same, right? So we got 0.236, right? Let's do this. Let's measure the same.
It only has these measurements.
No, those are just math. That helps you figure it out. So this measures things in eighths, right? So we know that we can see that 0.125 is 1/8, 0.375 is 3/8, right? It just helps you do math, and then it does 30 seconds on this side. So you can easily do math, right? So this works the same way, right? So we're going to put it in here, and I'm going to lock it. And we just did this measurement. Get that out of there. All right, so same thing. We're going to look at these numbers, and we got to 2, right? 2.5. So we got 0.2. And we're going to put the 2 here because I had to add it. Now, last time we got 236, right? And that would be, yeah, it'd be about the same, 11, right? So that'd be 236. But notice something. Does that line up perfectly with that line right there?
Nope, it's about 1.
It's about 1 notch past it. So let's go back and say 0.230. And then we'll look at this scale. This is called a vernier scale. See all these? It's a vernier scale. And what we want to do is we want to look for the one that lines up the best. And it's that one, the 9, right? That 9 right there is the one that lines up the best. So we would end up there. Wait, that's not right. That'd be 5. There we go. 5, 9.
It's a lot like this one, but only it doesn't have a ratchet.
Yeah, we don't have a ratchet on this one, but I don't use this. Actually, I use this one quite a bit because it's the one that's close. But that's how you read them. So I'm going to make you read these, and we're going to practice. It's hard explaining this. We're going to practice reading these. I just kind of do it in my head. It's kind of hard to explain, you know what? So you want to measure something else with that? What do you want to measure?
Let's see.
Yeah, you can't measure that. That's soft. It'll squish. Measure one of those. Get over here so I can see you.
We need a gap.
Use this one. No, measure the post of it, like this. We'll measure the gap too in a minute, okay? We'll talk about these two. measure that part. All right. What's it say? Get over here so you don't got your head in the road. So we got 2, 1, 2, 3. What's 25 plus times 3? 3/4. Because quarters are 25 cents, right?
25 plus 25, 50, 51. That'd be 70, 75.
75. So we know we're going to be at 275, right? Mm-hmm. And then we can add to that. So we know we're going to be at least 275, and then we go to 275 plus 5 is 80, right? 280, 285, 290, 295, 96, 97, 98. So we're at 298. You see how I got there?
Yeah, you just added.
I just added the numbers on the thimble, right?
Added.
I just added the numbers on the thimble, right?
Add.
So we'll work on this. That's the way I do it, because I don't want to have to do paper math when I'm working. So I figured out that would be 325 if it was 0, right? Mm-hmm. So it'd be 325, but it's not. So I got 325, 26, 27, 28, 329.
Do you also use your cheat sheet for this?
The cheat sheet is for drill sizes, though, right?
Oh.
They can't see that, but that's a drill size cheat sheet. But yeah, I sometimes measure stuff in thousandths and then go see what the closest drill bit is. I do that all the time. So I do that all the time. Now, these are micrometers to measure the outside of stuff, like we did with this Scribe, right? Mm-hmm. It measures that. Sometimes you got to measure the insides of stuff, and that's what this does. So you have this.
Inside micrometer.
It's an inside micrometer. You put this rod in there. It's got a rod stuck in there. I need to get it taken apart, don't I? Might be able to get that out of there real quick. It's going to be boring video. Watch me fix this, isn't it? Get out of there. There we go. That one's too short. Somebody broke it. Might have been me. I don't know. I haven't had this very long. So you put this in here, and you can measure and know how long this is, right? Mm-hmm. So we would know exactly how long this rod is, and it's kind of got marks on it if you look. Somebody's already got marked. And then we would add to that. So it's kind of like this. This one does up to 4 inches, right? So if I added enough rod, I could also do up to 4 inches, and then we would know exactly how far this opened, and we would read it the exact same way. You see how it's basically still a micrometer? Mm-hmm. It still has the exact same numbers, right? Mm-hmm. So it reads exactly the same way. We just add these rods, stuck in there. Needs to be cleaned. Add these rods to get our measurements, right?
I even heard the grease go.
Yeah. So, and you were talking about these ones earlier, right?
Yep.
So
they work like an inside caliper.
We'll get over here and you can show them how they work.
So
put it over here where they can see you. Explain how it works.
You put it in your engine.
You push it in an engine cylinder like that, right?
And
but you gotta get it where they can see it. All right. And if you had it inside the cylinder like this, you release it, and then it pops out, and then you tighten it again, right? Not tight, just snug. Because there's a technique to this. When you pull it out of the engine, you rock it like this, and then this finishes the measurement. Because right here, you're getting a measurement, but what part of this are you measuring on? See how that's pretty good.
You're kind of measuring where the piston goes.
Right, so this, when you wiggle it out a little bit like that, it sets this. And then you can take this, and you can take whichever appropriate micrometer you got, right? Snug her down some more. And it'd probably be the 4-inch one for this one, wouldn't it? You take this one, and then we would measure it like this, right?
We could do this technique on the spring.
We could. It would be this 3-inch. All right, so we're going to measure this, right? So this changes. All right, so we're going to go up here, and we're going to measure that. All right, so we're going to set it here where you can read it. And we need to remember that we're using the bigger micrometer now, right? So we're going to start with 2 point to get this one, right? Because it goes up to 3. It's 2 point something. And where's our numbers?
6.
6.
And 2 lines.
Now how much is 2 lines?
8.
No. 2 lines, each one's 25. 25 times 2.
50.
50. So 2.6, but we don't have to put the 5 down there yet because look, we got some extra, right? So let's do this, right? 50, are you looking? 55, 60, 61, 62. 2.6, yeah, 2.662. would be what that ends up. And you need to know that because if we're building engines, right, you need to make sure our piston rings are going to fit and that the piston's the right size. So we got these in several sizes. I got a whole set over there too, but these are the ones I leave on top of the box, right? So multiple sizes of those.
This is tiny.
Sometimes you got to measure small stuff.
Like this. Is there even a weed eater carburetor this size?
Maybe the carburetor, the cylinder, probably not. They can't see you though. You're over. But yeah, probably the carburetor bore might, but not this. The cylinder probably wouldn't be. It'd be pretty tiny, right? I bet they make airplane engines that small though. Little model airplane engines. I bet they make them small that size. We don't have any of those, right?
Maybe this is for a model airplane engine.
I think it's just a standard measuring device for whatever we want to measure, right? All right, one more.
Me. Our last treasure box of the day.
A treasure box, huh?
All right, get over
You
it.
gotta open it.
Oh,
Boom. All right,
it's another inside caliper.
kind of. It's not really an inside caliper. That's a depth caliper. So see this board here? I got holes in it, right? So if I wanted to measure this, I would screw this all the way out. We might do it. Well, let's just use the box. This thing. See, it's got a bore down there. If we thread this all the way out, we need a different. We need a different shaft. This has. See these? I need a different one to measure this. So we're going to start at 1 inch. So right there, right there should be 1 inch from here to here. We need a shorter one to measure this. But what you do is you put this in a bore, and then this would rest flat. Let's see if I can, like this, and where it's flat, and it measures how far between here and here, the flat surface and these legs, right? And that's how it works. But it reads just like a micrometer, except there's a huge difference. Hand me one of these, this micrometer here. Look at those things. You see a difference between them?
I think the thimble's shorter.
Nope, they're the same size. They measure the same inch. Look at the numbers.
They're different.
What's different about them?
This doesn't have these numbers.
Well, now, no, these numbers on the bottom.
These are smaller.
That's the only thing you notice that they're different?
It's 15 at 10.
Dude, that's all the measurements. I can put them both at 0. You're looking at all the wrong things. Look, where's it start? 0,
9.
0.
1. It measures backwards.
It measures backwards. You know why it measures backwards? Because it measures from this surface. This is measuring between these surfaces, right? But this is measuring from this surface. So it measures backwards. And the higher you go up, the less it's in there, right? So it measures backwards. But that is very complicated because if you're not paying attention and you read these a whole lot, you can easily mess up your math. Because if you start reading this and forget that this goes backwards, you might count backwards. Because instead of going, remember we said, watch, I'll show you how we can do it. We'll do a comparison, all right? So let's set it on that one. Let me set this in roughly in the same spot. Where are we at? 4. Close enough, right? Close enough. So that's at 4. So if we measure this, and remember how we measured it? What's that one say? It says 0.4, and then we're at 2 lines, right?
2 lines.
So 2 lines, but we didn't, so that's 50, but look, we're not quite to the 55, so that'd be 54, right? So we're 4, 5, 4. This one looks like it's in the exact same place, right? But notice what happens. First of all, are we to the 4? If it goes backwards, are we even to that number 4?
No.
We're at 3, right? And then we're going to be at 3. Move my thing here. We're going to be at 3, and we're above the 50. So we're going to be at 3, 5. I guess if I turn it the same way, we could be at 3, 5. Oh wait, 2. Oh, 2. Not a 5, 2. So even though they look the same, because this one goes backwards, it measures different because now instead of going 4 plus 50, I got to go 30 or 4 minus 50. That makes sense? So it goes backwards, and that messes me up a lot when I use this because I have a lot of trouble getting my brain to work backwards. But once you remember that, it gets easier. You know that it goes backwards.
I wonder what's inside this caliper that measures inside the bore.
It's just a thread. You know what? I think we'll have to edit out this big break, but I think I have a broken one. A broken micrometer? If I have a broken micrometer, we can look at it.
This big break might give people some time to look at all these measurements.
Well, there we are. So people don't take care of their tools very good, and micrometers work on really small threads, right? So put it back in there.
I'm trying to figure out how.
And get sidetracked and focus. So here is a broken one. I tried to fix it, but it was really froze up, and look what happened. Someone really hulked it. They also ground a chunk off there too. So someone really tore this up. It's not good, but here's what's inside of it. So what you have is a thread inside this tube, and then see these threads? These go in there, and what they've done is they've calculated how many turns this takes to go a full inch. This fractioning and this division, right? So they figured out how many turns this takes, and then they marked it. I don't think this one's even fixable though, right? Like, this is really, really bad. We might be able to use this. See this ratchet?
No.
This is the ratchet mechanism. See the teeth? That teeth goes in there, and when it's under spring pressure, it rides against these other teeth.
Well, where's the paw?
There isn't a paw. It grinds. It goes click, 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 click. Let's see. See if you can hear it. Hear it? It just clicks against these things. So there's something in there that it clicks against. There might not be all the pieces for that. Yeah, this is that part.
It looks like it's way too
Yeah, I don't think we
torn
have
up.
all the pieces for this. Let me see if it's in the
And
top.
it's really froze.
Maybe it's in the top here. Oh, there they are. They're in the top. See it in there? We might be able to take that out and use it somewhere, but yeah. So there should be some clickies in there, but it's not clicking. And I got stuck. Someone really boogered this one up though, right? If we could get this apart, which clearly someone else tried and couldn't get it apart. If we get that apart, we might be able to get the ratchet mechanism out of there, but I don't use them that much. See, it rides right on that little thing there. And goes
But if
click,
we
click,
ever
click.
need new micrometer jaws, we got some.
That
right
part
here.
might be usable because that's not too boogered up, right? That might be reusable. The anvil's good. It's
Looks
not
like
too
somebody
beat up.
shot a torch at it.
But you'd have to have the same brand. Look, this isn't even a Starrett. It's a Slocum. JT Slocum. So it's not even a Starrett. So it's not quite the same. So these parts wouldn't fit any of our Starretts. Someone really did booger that up though, didn't they? Look at that. They butchered this. That's how it works though, right? So you see all the parts? You satisfied? You know how they work?
Yep.
That's what makes them all work. I don't know why you keep the parts. It's not fixable. There's no fixing this. Maybe I can use the thimble somewhere. I don't know. I don't know why I saved that.
If you could just get it apart.
Yeah, I don't know why I saved that. It's gonna be good for nothing. All right, what else you got? You understand it all?
Yep.
All right.